Hi there guys, got a video here for you today on the FX DRS, and what we're going to be doing in today's video is remaking the hammer spring adjuster as well as making a hammer spring adjuster lock for the rifle. So we're remaking the hammer spring adjuster because the original one is brass, and over time the spring has worn against it and deposited a load of brass debris within the action. We're going to be making a new one out of stainless steel so this doesn't happen in the future. And we're also going to be making a hammer spring lock to stop the hammer spring adjuster from winding itself out over time. The factory one is held in by just Loctite, and once you break the seal, it is free to move about within the action. And what I found is when I was using the rifle, the adjuster was backing itself out, changing the power of the rifle. But with that said, we can get started, and the first thing we're going to be remaking is the hammer spring adjuster. Right then, so here we are over at the lathe, and the first thing we're going to be making is the new hammer spring adjuster, this piece here. This isn't finished yet, this is just the first operation, then we'll flip it round and finish the other side. But to begin with, we have this turned down section on the front here which houses the spring and acts like a spring guide. We then have a small boss at the back there, as well as the thread. The thread is M16 by 1, and we'll be cutting that using a single point cutter. To start off with, we've got a piece of stainless steel chucked up in the 3-jaw, and we're going to be using the roughing tool to remove most of the waste material from the front here. Then we'll swap over to a finishing tool. So let's get started. Right then, so that's the part roughed out. As you can see, the roughing tool doesn't leave a fantastic finish on the material. That's not a problem, as that's what our finishing tool is for. So we can use this just to take a very light pass over all the external features and get everything down to the correct size. This particular cutting insert is a VCGT one, and typically these are used in aluminium and non-ferrous materials to produce a real nice finish. They do work in stainless and steels, although they do blunt very quickly, and you do need to take a fairly light pass with them. So we're just going to take the light passes and remove some material. Right then, with a serviceable finish put on everything, the next thing to do is prep the part for the threads. To do that, we're going to be using a part-off tool to create a groove in the back here, which will act as a relief for the threads so that we can cut them into a gutter. The next thing we'll do is come back with a 45-degree chamfer tool, put a chamfer on the front here, as well as the leading and trailing edge of the threads, and then finally just chamfer this little edge here. Right then, last thing to do is cut the threads on this diameter here. As I said earlier, these threads are M16 by 1. We're cutting those with a full form cutter. A full form cutter cuts both the root and the crest of the threads, so the top and bottom, and just make sure the thread profile is perfect, so it should screw into the back of the block no problem whatsoever. So let's cut the threads. Right then, with the piece parted off, we can now start work on this side. What we need to do is face the end, give the threads a light chamfer, then drill a hole in the end which will be used for an internal hex. So we can use a Allen key to adjust the hammer spring tension nice and easily through the back of the rifle. I'll show you how we're going to do that very shortly, but first thing we need to do, get it in the 3-jaw and then face the end off. Right then, to finish out the component, we're over at the mill, and the last thing we need to do is mill the hex feature in the end of the adjuster so we can adjust it with an Allen key. To do this, what we're going to be doing is milling a series of holes around the ID, the rough diameter of our hex key. So if we take an Allen key, this one here, we can install that into the back of our hammer spring adjuster, and that allows us to adjust it when it's inside the rifle. This is the blank that you just saw me make, and this is one that's already been completed. So what we're going to be doing is sticking the adjuster in the collet here, and we can tighten that up. And then finally I've got a 2mm end mill installed into the collet juck, and we're just going to be milling those holes out. Right then, and that's our hammer spring adjuster complete. We can install an Allen key in the end there nicely, and that's ready to be installed into the rifle. The next thing we're going to make is the hammer spring lock to stop this winding out when the rifle is in use. Right then, the next thing we can make is the hammer spring lock. So this should look something like this when it's all complete. And what this basically is a jam nut to stop the hammer spring adjuster from coming loose. So this will tighten up onto the hammer spring adjuster and stop it vibrating loose while the rifle is in use. To make this, what we're going to be doing is facing off our piece of stainless steel, turning it down to 16mm, parting the disc off about half of the way through, at which point we can thread the piece, drill a hole through the centre, and then part the piece off fully. So we'll get that done first, then we'll flip the part round in the lathe and get the other side finished out. Right then, with that part parted off, the next thing we need to do is finish off the other side. So what we need to do is face it to make sure it has a nice surface finish. Then we can put the two holes in so that we can tighten this part up using either a set of snap ring pliers or a dedicated pin tool. To hold it for both of these operations, we're going to be using what I call a washer collet. So this part here slides in the 3-jaw like so. Then we take our hammer spring adjuster, put that in there, and then as we do the 3-jaw up, it tightens on the washer collet and holds that part in position. So we're going to be facing this side off, then we'll take it over to the mill and get the two holes drilled. Right then, so we've got our new components made and they're ready to be installed into the block. There are a few things that I've done off camera that I want to briefly go over. So the first thing I've done was remove the trigger, remove the hammer from the rear of the action, then give a good clean to the inside of the block, as well as the hammer and the trigger sear. I also removed all of the Loctite residue from the screw threads in the adjust up area, so everything inside the block is nice and clean and free of any brass debris. If you wanted to remove your hammer from the back of the action, all you would need to do on the standard rifles is remove these 3 screws here, and then push out these 3 pins here using something like a 1mm drill bit. On the rifles fitted with the match trigger, you do need to remove this trigger plate from the bottom here simply by removing these 2 screws and then removing them 3 grub screws and doing the same process as you would do with a regular rifle. With that said, the other thing I've done is give the hammer spring a good polish up. So FX springs are normally pretty good, but where the ends are flattened and then ground, they do sometimes have a burr on both the inside and outside edges. So I've just gone through the spring and given it a good polish up, as well as removing all of the old brass residue. So that's ready to go back inside the rifle. On sort of a tangent note, I do get a lot of comments specifically on Facebook saying that polishing these springs doesn't really do anything and it's a waste of time, but I disagree. Having the ends nice and smooth just stops different components from wearing, such as the hammer spring adjuster, and if you look here you can see where the original spring has eaten into the side of the adjuster. So that was the cause of the brass debris being left inside the rifle. And you'll probably find that if I were to reinstall the polished spring as well as the original hammer spring adjuster back into the rifle, the rate at which the side of the adjuster was wearing would be greatly reduced. Not only that, but polishing the components up just makes sure that everything spins nice and smoothly and there's no binding or grabbing as the spring is compressed. So there we have it. Right then, next thing we can do is get our components installed into the block, and that's nice and simple. The first thing we're going to do is take our hammer spring and just put that into the back of the block, making sure it seats nicely in the back of the hammer. The next thing I'm going to do is install the hammer spring adjuster screw, but before that goes in, I am just going to be adding a small amount of dry lube to the shaft and also the boss. The dry lube just acts like a lubricant between the metal-to-metal contact of the spring and the adjuster and just makes sure everything slips and slides nicely. This is optional, you don't have to put any lubricant whatsoever in your hammerway if you don't want to, but I'm doing so just as an added precaution. So that can go in the back, then get that lightly done in by hand, then we can take our 4mm Allen key and do that in roughly. The next thing I'm going to be doing is getting my hammer spring lock installed, and to get that installed I am going to be using just a pin tool that I quickly made off camera, so that pushes in there like so, and that gets done up. We're not going to be doing this up tight just yet, as we do need to set the power on the rifle before that gets locked into position. If you didn't want to get the pin tool, you could also use a set of snap ring pliers to put the lock into position, but I'm just using my pin tool for now. So the next stage would be to put the rifle over the chronograph and set the power where you want it. Up next, you can use the pin tool or a set of snap ring pliers to just get the lock done up nice and tightly. And with the hole in the centre of the lock, you can just use a 4mm Allen key to adjust the hammer spring tension as you do your lock up. So let's say we wanted to adjust our power to roughly there. We would leave the Allen key in place, tighten the lock up nicely, then test the rifle over the chronograph. If we needed to make further adjustments, we'd simply loosen the lock, adjust our power, then put the lock back into position. Doing the lock up hand tight will stop it from coming loose in the short term, but once you've found the position in which you want to lock your hammer spring, you can just use a spanner against the pin tool, get that done up into position, and the hammer spring adjuster should not move from that position. Right then, the last thing I want to mention is just some key dimensions to keep in mind. So the first dimension I want to mention is the distance between this face here and the back face here. So on the original hammer spring adjuster, this is 4mm. On the new one, it is 5. There is just a little bit more thread engagement on the new adjuster than there was on the old one. And the other thing I'll mention is that the lock is 3mm thick, so 3mm from face to face. The reason that I mention these dimensions is just in case your hammer spring is either flush or just shy of the face here. To install the lock, you need at least 3mm between the back face of the block and your hammer spring adjuster. And if you were to install the new hammer spring adjuster as well as the lock, you would need at least 4mm. But just something to keep in mind, I will have a few of the hammer spring adjusters and the locks on my eBay store coming next week. It's currently bank holiday weekend in the UK, so they'll be coming sometime early next week. But for now guys, that's pretty much going to do it for this particular video. Thanks very much for watching, and I'll see you in the next one.